Good morning and welcome to AP Statistics for Wednesday, April 1st. All right, today we're going to talk about the homework assignment I gave you for yesterday, which was on page 657, number 44. Just going to give you a quick summary of it. You have the information in front of you. It had to do with rowers and the training that they were given and whether the skilled rowers were showing a difference in some sort of knee angle as compared to the novice rowers. Well, pretty clearly, if that were the case, we should see, it said, a larger degree difference in the skilled versus the novice. So the mean difference, if we have an actual successful test here, would be a positive difference. They gave you the skilled rowers angles first. So skilled minus novice, if skilled has a higher degree than novice, would be a positive number. So the alternate is greater than 0. The null can be equals 0, equals, or it could be equals or less than. It doesn't matter. Okay. If you looked at the conditions as given, they did check out. You could, of course, certainly write it down, and you should write it down very specifically. The sample sizes were small, but it was given that there was no skew or outlier in the data. It told you it was a random survey, and obviously there could be far more rowers in the world than 10 times the ones that were surveyed. The t-score for this would have been 4.182 minus 3.01 minus 0. Again, the difference in the means was supposed to be no difference in the means, so we're just going to say minus 0. You don't really have to keep writing that if you don't want to, but sometimes when there is a difference expected, you want to remember that it's important. Okay, so our denominator, as given, would have been a t-score of 3.156. You remember, of course, from t and from z that 3 point anything is pretty far away from center, so we're probably going to have a small p-value. The sketch of the curve would have had your 0 in the center. This was your t statistic pretty far out to the right. We're going to shade that little upper corner because the alternate said greater than, and we shade the right tail. TCDF for this would have given us 3.156 to an infinite bound with 7 degrees of freedom because the smaller sample size was 8. And that will give us a p-value of 0.008, obviously lower than the alpha. What do you do when the p-value is lower than alpha? Well, you reject the null. So we're going to reject the null that the mean difference was 0. The evidence was significant enough for us to say that there was a true difference between the two populations and that the skilled rowers did have a significant increase in the angle measure of the knee and whatever else it said. All right, so that gives us our answer for yesterday's prompt. Now listen, today we're going to talk about what to do with raw data. So we're not always given the compiled information. Sometimes we're given a set of raw data. I'm going to walk you through an example today, and that's going to be how we're going to look at this. So I'm going to tell you a story. We have a simple random sample of managers and account representatives from a specific company. We presume that there is a $7,000 difference in their average salary based on past history. But we're going to see now if our new samples will help us to say whether or not that is still the case. Okay, so I'm giving you the information about the managers and the reps. And I'm going to give you their annual salaries in thousands of dollars. And we're only going to look at 6 people. 1, 2, 3, 4, 5, 6 people from each of those job descriptions. And here's how much money they made. The managers made, one made 80,000, one made 92, one made 87, one made 75, one made 98, one made 85. They're in no particular order. And here's the account representatives. One made 71, 62, 85, 80, 80, and 68. Again, in no particular order. So the question was, we expect them to have an average difference of $7,000. Is that still the case? Well, let's check the conditions before we do anything else. Okay, so I have my conditions for the manager. Actually, I'm going to put that over here. So we got the manager and the reps, and I need to make sure that my conditions are going to verify. So what do I need to do? Well, what about the SRS? Did I mention it was an SRS? I sure did. I said it was a random sample, so that was given for both. What about the 10% rule? We have to presume that there can be at least 60 managers in this company or in this field or in this world or overall time, and that's a safe estimate. We also have to say that there could be at least 60 account representatives. Again, a pretty safe bet. And the final condition is the normality. So where the population is normally distributed. You don't know, because I didn't tell you. So we can't go with that. Were the sample size is at least 30. Well, we have 6 and 6, so that's a big no. So the question is there skew or outlier in the data? Now, what I'd like you to do is on your graphing calculator, enter those two lists of information into list 1 and list 2 if you didn't already, and make a modified box plot. If you make the modified box plot for each list one at a time, you'll see whether list 1 or list 2 has any strong skew or outliers. Ideally, you should sketch that box plot. So I'm just going to make a little box plot for what I think it looked like. I don't have my calculator on me right now. But what I saw when I looked at it before was that there was no strong skew and there were no outliers at all. So that allows us to move forward. And kind of in backwards fashion, I'm going to put my summary data down below here. So we had N, I want to know X bar, and S sub X. We already know the sample size was 6 for both. If you use your calculator's one-var stat function, you'll be able to find the mean and the standard deviation with no difficulty at all. So the managers had a mean of 86.1667, and the reps were 74.3333. Standard deviations were 8.2321 and 8.7331. All right, so again, we already expected them to have a difference. What we're expecting is a $7,000 difference. The question we're looking at here is, does the data support whether or not we truly will have a $7,000 difference, or has that difference changed? Well, what were the statements for that? What's my null and what's my alternate for this? I'm expecting a mean difference of what? It's not 0 this time. I expect a mean difference of $7,000. And since we're measuring everything in thousands of dollars, I don't write 7,000. I'm going to write that my null statement is the mean difference equals 7. I'm expecting a $7,000 difference. Okay. The question was not, do the managers make more money now than before, or do the reps make more money now than before? Just, is that difference still existing? So, does not equal 7. That's going to be my alternate. All right, good. It's our first example of one that doesn't have a 0 difference expected, which also means that our equation for the t-score is going to hinge on that number 7. So, what is my t-score for the difference going to be? Well, it is the difference between the sample means, 86.1667 minus 74.3, repeating, minus 7. See, my numerator now involves that minus 7. It's the expected difference between the two populations. Because I gave you that there was an expected difference, we're going to use 7 there. The denominator is what it was before. It's the square root of, and we have here 8.2321 squared over 6 plus 8.7331 squared over 6 Both sample sizes happen to be 6 this time, so that's why we're using 6 there. And that gives me a t-score for the difference of 0.9865. So this particular sample falls less than 1 standard deviation away from a zero, not a zero difference, less than 1 standard deviation away from a $7,000 difference, which, as we know, it's pretty close. So the p-value probably going to be kind of large. Let's just see. How do I find the p-value? Well, that's TCDF from, and I do still want to make a sketch. I'm going to do a quick one over here. There's my 0. There's my 0.9865. It's two-tailed, so there's also a symmetric one on the left. So 0.9865 to an infinite bound with how many degrees of freedom? Well, this time they're both samples of 6, so the degree of freedom is just 5. And that gives me a p-value for one tail of 0.1846, but we have to double it because this is a two-tailed test, and that's 0.3692, which is far larger than any alpha is going to be. So, what is our decision when our p-value is larger than alpha? We fail to reject the null. We are going to fail to reject. We cannot reject the null that the average difference is still $7,000. Even though our sample data revealed a difference that was closer to about $12,000, the sample sizes were so small that it wasn't significant enough to tell us that there truly is a larger difference than there was historically. And that is the pattern. That's the rule. That's the procedure. So we've seen our 2 sample means tests with compiled data, and now we've seen them with raw data as well. All right. There's not much more that we're going to do with this chapter. So digest the information, maybe try it yourself, maybe even open your book and look in the review section, pick a problem and do it. But this is the entire procedure for our chapter, and there's no homework tonight. All we're going to do is take a day off of homework, also of me having to collect homework. And tomorrow, what I'm going to post for you is a quick little summary, as well as a worksheet to review 10.2. And we're going to work our way on towards a test, probably in the middle of next week. Okay? We're not in a hurry. We're doing fine on time, even if we were still in school. So, that's all I have for today. Have a great day.